Hello there, and a very warm welcome to the Midnight Scientists. You've found your way to this quiet corner of the cosmos, a place where curiosity and calm can gently meet. Here, in the stillness of this moment, we allow the wonders of the universe to gently, softly, rock you to sleep. Before we begin our celestial journey tonight, I wonder, where in the world are you listening from? And what time is it for you right now? If you feel inclined, you can let me know in the comments below. It's always a quiet joy to know how many of us are drifting together, connected from all the different corners of our world. And if you find a sense of peace on our voyage this evening, you might consider giving this video a gentle like and perhaps subscribing to our channel. That way, you'll never miss our next stargazing session. Your simple click helps other sleepy minds find their way here, to this calm harbor. Now, let tonight's story begin to unfold. It is a beautiful one, a story of how those sprawling cities of stars we call galaxies are born from the deepest darkness and the finest dust. I do hope it's not so interesting that it keeps you awake, but if it does, well, you will simply know a little more about the early universe before your morning coffee. So, for now, just settle in. Let your shoulders gently drop, releasing the day. Take a slow, deep breath in and a long, soft breath out. You are about to drift through 13.8 billion years of cosmic history. There is no rush at all. The stars, they will wait for you. Let's begin. 13.8 billion years ago, the universe was small. Not just small in the way you might think of a cozy room, but unimaginably, infinitely compact. It was hotter than the very core of a star, and denser than anything we can truly comprehend. And then, in a moment that defies our fullest understanding, it began. It wasn't an explosion, despite the name we've given it. The Big Bang was more of a rapid, graceful swelling, a cosmic exhale. Space itself, the very fabric of reality, expanded outward in every direction, faster than the speed of light. Imagine a beautiful balloon, not being violently burst, but being gently and swiftly inflated, with a soft, cosmic breath. There was no debris flying through empty space, because space was the debris, and it was making itself as it went. In those first fleeting, precious microseconds, the universe was a swirling, seething broth of fundamental particles. Quarks jostled with gluons, photons zipped around like restless fireflies, and gravity, ever the patient sculptor, quietly began to make its notes. It was a chaotic, blindingly hot, and incredibly bright beginning. Not a place for stargazing just yet. But this early universe, for all its untamed energy, was filled with an immense and beautiful potential. The simplest, lightest elements, hydrogen and helium, began to form like the first cosmic Lego bricks snapping together from the charged chaos. These humble, gentle atoms would go on to build everything, the stars, the planets, every living thing, and of course, the galaxies. About 380,000 years after the Big Bang, a mere blink in the eye of the cosmos, something truly beautiful happened. The universe cooled, just enough for those newly formed atoms to capture electrons creating the first stable, neutral atoms. And in that moment, light, which had been trapped, ricocheting endlessly like a firefly in a jar, was suddenly set free. This moment, known as recombination, created what we now call the cosmic microwave background. It is the soft, gentle afterglow of the Big Bang, a hum that still resonates through the universe today. If your eyes could see in microwaves, the entire night sky would glow with the faint, ancient light of that very first fire. But despite this gentle, pervasive glow, there were no stars. There were no galaxies. Not yet. The universe at this point was a vast, dark, expanding cloud of gas and potential. If you could drift through it, you would see nothing but subtle, beautiful ripples, tiny, almost imperceptible irregularities in the otherwise smooth distribution of matter. And these ripples, they were everything. They were the echoes of quantum fluctuations from the very first moments of creation, stretched across the cosmos by that initial, rapid inflation. Some regions were just ever so slightly denser than others, a difference so small it's hard to imagine. But gravity noticed, and gravity does not forget. Over vast stretches of time, over millions of years, those denser pockets of hydrogen and helium began to gently pull in more and more material. Slowly, softly, they gathered, like cosmic dew forming on an invisible spiderweb. These clumps, the very first seeds of future galaxies, were utterly invisible to the naked eye, if eyes had existed. But they were already setting the stage for all the dazzling drama that was to come. It's a strange and peaceful thought. The universe is quiet. In this era, there was no light from stars, no glowing galaxies, just the faint, gentle murmur of matter falling into itself. It was a time of profound stillness, a long, deep breath in, before the universe exhaled its very first starlight. The stars had not yet arrived, the galaxies still slept, and for a few 100 million years, the universe remained cloaked in what we now call the cosmic dark ages. Despite the ominous name, this was a time of peaceful, quiet gestation. This was darkness in its purest sense, a universe full of matter, but not yet light. After the Big Bang's brilliant opening act, and the soft, fading glow of the cosmic microwave background, things settled into a deep and profound hush. Neutral hydrogen gas filled all of space, like a vast, invisible fog. There were no stars to shine through it, no galaxies to twinkle in the immense distance. The universe had gone dim, not because it lacked energy, but because it hadn't yet figured out how to turn the lights on. Imagine, just for a moment, floating through this time, an infinite expanding sea of cool hydrogen and helium, the occasional electron drifting by like a lazy, ethereal jellyfish. There is gravity, pulling ever so gently on the gas, forming clouds here and there. But everything moves at a pace that is almost impossibly slow, glacial. Not that time meant much then. There were no clocks, no days, no sunrises. Just the slow, patient accumulation of mass in a universe that was not yet in a hurry. Yet something extraordinary was quietly, silently unfolding in this shadowy silence. The groundwork for everything we know was being laid. During that initial, lightning-fast expansion, tiny quantum fluctuations were stretched across the vastness of space, and these little wiggles in density, these subtle variations, were all that gravity needed. Where matter was just a tiny bit denser, it began to draw more of itself in. Over hundreds of millions of years, these ripples grew into delicate tendrils and soft knots, what we now call the cosmic web. Think of the universe as a vast three-dimensional sponge, or perhaps a delicate cosmic spiderweb, strung together by invisible filaments of dark matter and gas. These filaments are where galaxies would eventually form, gently pulled into place by the persistent, patient hand of gravity. The empty spaces in between, the voids, would become giant, lonely stretches of near-nothingness where almost no stars will ever shine. And at the center of it all was a silent, invisible partner, dark matter. It doesn't glow. It doesn't reflect light. It is famously elusive. But dark matter was absolutely essential. Its gravitational influence shaped the very scaffolding of the cosmos, pulling the ordinary matter, the hydrogen and helium gas, into place, like the hidden frame beneath a magnificent painting. Without dark matter, the universe might have stayed a foggy, formless cloud, forever. And then, it happened. Somewhere deep within one of those collapsing clouds of hydrogen and helium, gravity tightened its gentle, relentless grip. At the very center of that dense, invisible swirl, pressure soared, and temperatures climbed to millions of degrees. Atoms were pushed so close together that their very nature began to change, and in that moment, almost certainly unnoticed, unceremonious, a star was born, the very first light since the Big Bang. These were no ordinary stars. Known to us as population 3 stars, they were unlike anything we see in the universe today. They were enormous, unstable, and incredibly, brilliantly hot. They formed in the purest conditions the universe has ever known, made of only hydrogen and helium, the pristine remnants of the Big Bang. This purity made them burn hotter and faster than any stars that would come after. Some may have been hundreds of times more massive than our own sun, living short, furious, beautiful lives, before collapsing into black holes or exploding in brilliant supernovas. If you were floating nearby, you would see these first stars lighting up their surroundings like magnificent bonfires in a vast cosmic forest. One by one, their light pierced the ancient fog of hydrogen that had filled the universe. Slowly, gently, the darkness began to lift. This period is called cosmic rionization. The powerful ultraviolet light from these newborn stars began to strip electrons from the neutral hydrogen around them, ionizing it, and making the universe transparent once more. It was as though someone had gently cracked open the shutters of a vast cosmic greenhouse and let the light flood in. We cannot see these first stars directly. They were too brief, too distant. But their fingerprints are everywhere. They transformed the universe from cold and dark to warm and glowing. and in their explosive deaths, they seeded the cosmos with the very first heavy elements: the carbon, the oxygen, the iron, the building blocks of everything more complex than hydrogen, including you and me. In a way, these stars were the universe's first artists, sketching the faint outlines of galaxies on the blank canvas of space. The universe was glowing now, not brilliantly, but more like the very first soft hint of dawn on a cool, quiet morning. The stars had arrived. Their light was unraveling the fog, warming the deep silence, but they were scattered, isolated, flickering across the dark like distant, lonely campfires. There were no cities of stars yet, no grand structures, just lonely pockets of light, suspended in the immense void. But gravity, as always, had other plans. Those scattered stars weren't just floating randomly. They were being drawn together by invisible, gentle threads. Small clumps of stars were converging. Gravity was quietly threading them into larger, more complex structures. The villages were becoming towns. The towns would soon become cities. And these cities, these proto-galaxies, were the very first drafts of the magnificent galaxies we know today. It did not happen neatly. There were no blueprints, no cosmic engineers. It was messy and beautiful. Clumps of stars and gas collided. They merged. They were ripped apart by gravity. And then they merged again. The early universe was a dynamic, active place. Gas clouds crashed into each other, triggering brilliant bursts of new star formation. Some early galaxies formed quickly, growing fat on nearby gas and gobbling up their smaller neighbors. Others stalled, stranded in the quiet corners of space. At this stage, galaxies didn't look like the elegant spirals we see in telescope images. They were irregular, chaotic, unrefined, more like beautiful glowing space blobs than symmetrical structures. And yet, even in their chaos, they were growing. Slowly, their shapes began to stabilize, nudged by gravity and sculpted by their surroundings. Much of this early architecture was influenced by that vast, underlying structure, the cosmic web. Those dense knots where filaments of dark matter intersected became the hubs, the regions where galaxies would cluster, like seeds finding the richest soil. And it's in these dense intersections that proto-galaxies would engage in a slow, cosmic dance that could take hundreds of millions of years. When galaxies crash into one another, it is not a violent collision in the way we might think. Stars themselves are so far apart that they rarely, if ever, hit each other. Instead, their gravitational fields become entangled. Tidal forces twist the galaxies into strange, beautiful shapes. Streams of stars are pulled out like taffy, trailing behind their original homes, and the great clouds of gas do collide, compressing violently and sparking incredible new waves of star formation, what astronomers romantically call starbursts. And so, galaxies began to find their form. They are not uniform. They come in many beautiful shapes and sizes, much like snowflakes, if snowflakes weighed a few 100 billion suns. Some spin elegantly, like cosmic pinwheels frozen in space. Others are squat and round, like celestial dumplings. But how did these beautiful shapes arise? Let's start with the spirals, the show-offs of the galaxy world. Spiral galaxies are among the most beautiful structures in the universe. Our own Milky Way is a spiral. They have graceful, curving arms and luminous cores, like cosmic hurricanes caught in a moment of mid-swirl. Spirals tend to have lots of gas and dust, the prime ingredients for making new stars, so they are full of bright, young, blue stars, lighting up their arms like festive fairy lights. The structure of a spiral is all about motion, a gentle, orderly rotation that flattens the galaxy into a disk over billions of years. Density waves ripple through that disk, like traffic jams in space, compressing the gas and sparking the birth of new stars. Then, there are the elliptical galaxies, older, rounder, and generally a bit more relaxed. These galaxies are more like giant, glowing star clouds, shaped like spheres or stretched out rugby balls. They are usually composed of older, redder stars, with very little gas left to make new ones. If spiral galaxies are bustling cities, elliptical galaxies are like sleepy, peaceful retirement communities. They likely form when two large spiral galaxies merge. The orderly motion of the stars is disrupted, and what's left settles into a big, beautiful, shapeless mass. And then there are the irregular galaxies, the non-conformists. Some are young galaxies that haven't had time to settle into a shape. Others are older galaxies that have been pulled out of alignment by a larger neighbor. They might look like splatters or scribbles, but they are often bursting with the energy of new star formation. And the shape of a galaxy tells us its story. A spiral galaxy likely had a calmer upbringing. An elliptical one probably saw more action, more mergers in its past. And the irregulars, well, they are the wild, untamed youth of the cosmos. And even now, galaxies continue to change. They are not static. They are dynamic, living systems of stars and gas and dust, constantly evolving. Let's come home for a moment. We've been drifting through the vast, impersonal universe. But now, it's time to return to our own special corner of the cosmos, a place that is familiar, not because we've seen it from the outside, but because it is where every human story has unfolded. We live inside a galaxy called the Milky Way. From our place within it, we can't see the Milky Way as a whole. It's like trying to read the label from inside the bottle. What we do see, on a clear, dark night, is a glowing river of light stretched across the sky. That shimmering band of starlight and dust is our view across the galactic plane. We are looking edge-on through billions upon billions of our stellar neighbors. The Milky Way is a large spiral galaxy, about 100,000 light-years across, containing somewhere between 100 and 400 billion stars. We are tucked into one of its arms, the Orion arm, about 2/3 of the way from the bustling center. At the heart of our galaxy, there is a supermassive black hole, Sagittarius, a star. It is a gravitational heavyweight, about 4 million times the mass of our sun. It anchors our entire galaxy, and stars whirl around it in dizzying silent orbits. Our Milky Way has a long and storied past. It grew by merging with smaller galaxies, and it is still doing so. Right now, it is slowly pulling apart and absorbing the Sagittarius dwarf galaxy. And in the distant future, in about 4.5 billion years, our Milky Way is set on a slow-motion collision course with our nearest large neighbor, the Andromeda Galaxy. When they merge, they will likely form a new, even larger elliptical galaxy. Some have suggested the name Milkomeda. And through all of this cosmic drama, our tiny star, the Sun, just keeps orbiting. It takes about 225 million years for our solar system to make one complete lap around the center of the Milky Way. The last time we were in this galactic neighborhood, the dinosaurs were just beginning to roam the Earth. We are spinning quietly in one of the galaxy's beautiful spiral arms, a pale blue dot circling an unremarkable yellow star, wrapped in the soft, ancient light of a billion suns. If galaxies are the great cities of the cosmos, then what built them? 3 unlikely architects have been quietly at work since the very beginning: gravity, dark matter, and black holes. Gravity is the great gatherer. It is slow, patient, and it never stops working. In the early universe, it took those tiny, faint ripples in the density of space and began to amplify them, drawing matter together until stars and galaxies could form. But gravity alone wasn't enough. When astronomers measured how fast stars were spinning in the outer parts of galaxies, they found they were moving too fast. They should have been flung off into space. This led to the realization that there must be more mass than we can see. This is dark matter. It is an invisible substance. Yet we are certain it exists because of its gravitational pull. For every visible star in a galaxy, there is a much larger, invisible halo of dark matter holding everything together. It is the invisible scaffolding of the universe. And at the heart of nearly every large galaxy, including our own, sits a supermassive black hole. We used to think of them as mere passengers, but we now know they are more like co-authors of a galaxy's story. When they feed on gas and dust, they release enormous amounts of energy that can regulate the growth of the entire galaxy, sometimes halting star formation for millions of years. It is a beautiful irony that the darkest things in the universe are also the ones that help hold it all together. To gaze into space is to gaze into time. Light takes time to travel. The light from our sun is 8 minutes old when it reaches us. The light from the Andromeda Galaxy began its journey over 2.5 million years ago. With our telescopes, like Hubble and the James Webb Space Telescope, we can peer back billions of years, almost to the very beginning of time. We are, in a very real sense, time travelers. Every image of a distant galaxy is a photograph of the past, a snapshot of a moment so distant it feels like a dream. But it is real. The universe is still evolving. Galaxies are still gathering in groups and clusters. Our own local group is part of the vast Laniakea supercluster, a structure of over 100,000 galaxies drifting together through the cosmos. And yet, the universe is also expanding, faster and faster, due to a mysterious force called dark energy. In the far, far future, galaxies not bound to us by gravity may vanish from our view entirely. The universe will grow colder and quieter, but for now, there is still so much light, so much beauty, so much to wonder at. And now, after billions of years and billions of light years, we have come to the end of our journey for tonight. We have drifted from the birth of the universe to the birth of galaxies. We've watched stars flare into life and seen galaxies collide in a slow, graceful ballet. It is humbling, isn't it, to know that the stars above you are not just points of light, but memories, that galaxies are not still images, but stories still unfolding, and that every atom in your body was forged in the heart of a long-dead star. You are made of galaxy stuff. You are a part of this story, and perhaps that is why we find the night sky so comforting, because some ancient, quiet part of us remembers what it feels like to drift through starlight. So now, as your eyes grow heavy and your thoughts soften, just let go. Let the stars keep their silent watch. Let the galaxies keep spinning, just as they always have, and just as they always will. Good night, fellow traveler. You are home among the stars. Sleep well, my dear listener. Sleep well. See you in the next episode.